I was just thinking about the physics of
Yeah.
grabbing a Pringle chip. It's kind of perfect. You reach in, and the whole stack just comes with it. But then they just snap apart so cleanly. That can't be an accident. That reproducibility has to be by design.
Oh, absolutely. It's a masterclass in engineering.
And that's what we're diving into today. We're looking at a source that connects that salty snack to some pretty advanced geometry. There's a 3D graph, an equation.
It's all there.
Okay, so let's unpack this. So if you're looking at the source material with us, you see the chip right next to this this grid-like mathematical surface.
Yeah.
It's obviously not flat, but what are we actually looking at here? What is that shape called?
So that shape is what's known mathematically as a hyperbolic paraboloid.
A hyperbolic. Wow.
Yeah, but most people just call it a saddle surface.
The saddle. Okay, that makes sense.
And what's so fascinating about it is that it has two opposing curvatures at the exact same time. So if you trace it one way, lengthwise, it curves up. It's convex. But then you trace it widthwise, perpendicular to that, and it curves down. That's concave. So it's curving up and down simultaneously at every single point.
Wait a second. Is that opposition, the convex and the concave working together, is that the secret to why they stack so well?
That's it. That's the key.
Because if they were just, I don't know, a simple bowl shape, you'd lose all that stability, wouldn't you?
You'd lose everything. If it were a simple bowl, any force on the edge would just go straight to the center and crack it.
Huh.
But the hyperbolic paraboloid, because of those opposing curves, it actively distributes that stress across the entire surface. It's geometrically optimized to resist that crushing force.
So the packaging problem is solved before the chip is even made.
Precisely.
Okay, this is where it gets really interesting for me. The source gives us the actual formula, the math, that guarantees this shape. It's z equals x squared over a squared minus y squared over b squared.
And looking at that formula, the real hero of the story is that minus sign.
The minus between the x and y terms.
That's the one. That difference is what mathematically creates the opposing curvatures. It's literally what generates the saddle structure. If that were a plus sign, you'd just have a dome or a bowl.
That makes perfect sense for the surface shape, but an equation like that, it describes a surface that could just go on forever.
It could, yes. An infinite surface.
So how do they stop it? How do you get that specific oval boundary that fits so perfectly in the can?
Well, that brings us to the second piece of math in the source. There's another expression there.
The x squared over a squared plus y squared over b squared is less than 1.
Exactly. That little inequality isn't defining the height, like the z value. It's defining the boundary. Think of it like a mathematical cookie cutter.
Oh, I see.
It's the instruction that tells the surface exactly where to stop. It defines the domain, giving you that precise, repeatable edge for every single chip.
That whole dive into complex structural design, it makes me think about precision engineering and optimization. This deep dive is sponsored by Embersilk. If you need help with AI training, automation, integration, or software development, or if you're just trying to figure out where AI agents could make the most impact for your business or even your personal life, check out embersilk.com for AI needs. So, to recap, we went from a simple snack food to a sophisticated mathematical equation. A hyperbolic paraboloid, a shape that resists crushing, stacks perfectly, and solves a huge logistical problem. That is just applied genius.
It really is. The ability of engineers and mathematicians to translate a concept from pure geometry into something so tangible.
And reproducible.
And successful, yeah. It just showcases the incredible power of applying pure mathematics to solve real-world challenges. It's a beautiful testament to human ingenuity. It shows you that even the simplest objects around us can hold this incredible mathematical beauty and deep engineering insight.
A perfect blend of crunch and curvature. If you enjoy this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.